So we've looked at two different types of rigid motions now. We've looked at translations and we've looked at reflections. And so now we're gonna think about what would happen if we combined those together. So that's called a composition of rigid motions. It's where we perform two or more rigid motions, where the second rigid motion is performed on the image of the first. So as an example here, we have a description of what we would call a composition of rigid motions. We're taking triangle ABC and we're doing two things to it. Now, if you look at the way this is notated, we see the R and we see the T. The R stands for a reflection and the T stands for a translation. But even though the R in the way this is written is coming before the T, what's really happening, you can see, is that we are translating our triangle first, and then we are going to reflect it across line L. So it's kind of the way you would read that to kind of maybe make sense is it's a reflection of the translation of triangle ABC. So we can see the translation is happening first and then it's being reflected. And that little small open circle right there is indicating that we are doing both of these rigid motions to our object right here. So if we were to like maybe sketch out what's happening to our triangle, we can kind of maybe do that a little bit. We would have maybe a triangle called ABC. All right, so maybe this is point A, and maybe this is point C, and this is point B, or point C. We're going to move that 2 units to the left, because remember that first number there talks about the horizontal movement with negative being to the left and positive being to the right. We're going to move it 2 units to the left and then 5 units up. So I maybe should have done this in a different spot. Let me just do that over again. Let me get rid of this guy here, and maybe I'll move this up a little bit. Here we go. Now I have more space. So let's say we have triangle ABC here, triangle ABC, and now we're going to take all of these points, these corners, we're going to move them maybe 2 units to the left and 5 units up. So maybe that means we go over by about that much and then up by about that much for all of these these 3 vertices. I was trying to talk and draw at the same time. So now we would have A prime here, we'd have C prime there, and we'd have B prime there. So our new triangle would maybe look like this after being translated. Then let's say we have a line of reflection, and let's just put our line of reflection maybe right there. So maybe that's line L. So now what we're going to do is we are going to flip that. We're going to reflect or flip this triangle A prime, B prime, C prime across this line L. So now remember that when we flip things, we're kind of taking each point, moving it along a line that's perpendicular to our line of reflection. That might have gone a little bit too far there. Let's take a little bit of that off. And so that C prime is going to go there. That would be like C prime prime maybe. And this will be A prime prime. And this would be B prime prime, so that our new shape, our new triangle, is now right there. And so you can see what we did first is we translated it up and then reflected it across line L. So that's the idea of a composition of rigid motions. Now let's look at an example where we're actually going to be doing 2 translations. So we're doing this in the context of somebody maybe dancing on this kind of checkerboarded dance floor here. And so it says, in learning a new dance, Kyle moves from position A to position B, and then moves to position C. So you can see he's kind of doing 2 translations. He's moving first to A and then over to B. What single transformation describes the move from position A to C? So I want to kind of write this out a couple ways. First, I'm going to write this out as if we are translating Kyle's position by 2 different translations. Okay, so we are going to translate. We're going to take Kyle. I'm going to write Kyle here, and we're going to translate him 2 ways. First, we're going to translate moving from A to B, which we can see is a movement up 2 and then right 2. So that would be a translation of 2 comma 2. Then from that point, we're moving, let's say, right 1 more and then down 1. So that would be a translation that is right 1, down 1. So this would be one way here to describe this translation of Kyle, moving him up 2 and then right 2 and then up 2, and then right 1 and down 1. Or we could look at Kyle moving from A, going right 3 and up 1, if that's just going directly from A to C. So, or we could say that we are translating with a movement that's right 3 and then up 1, we're translating Kyle. And that's what's taking him to his new position. And what you'll maybe need to notice is that if I just looked at this composition of two translations, and I looked at those numbers, it should seem kind of obvious how that combination of two translations could be described as this single translation, right? A translation of right 2, up 2, followed by right 1, down 1, would result in the same thing as if we just went right 3, up 1, because 2 added to the 1 would give us the 3, and then this 2 plus this negative 1 would give us this 1. So now let's apply that same idea to a couple more examples where a certain object is being translated 2 times. In example A, we can see that it's being translated to the right 3, down 2, and then right 1 more and down 1 more. So this translation would be the same as doing a translation of, let's say, 3 plus 1 followed by negative 2 plus negative 1. So if I clean that up a little bit, it would be a translation of to the right 4 and then down 3. In the second example, we can see here we're doing a translation that goes left 4 but doesn't move up or down, followed by one that goes left 2 more and moves up 5. So that new translation could be described by saying it's a to the left 4 plus to the left 2 more, and then not moving up or down, followed by moving up 5. And so that would be a translation that would move 6 to the left and then 5 up. Now the last thing we're going to take a look at in this video is there's a relationship between translations and reflections. So if I looked at this diagram right now, and I viewed triangle ABC here getting translated over here to where A prime prime, B prime prime, and C prime prime are, right? So it's just being slid over. One way you could think about doing that is by taking it, flipping it over once, and then flipping it over again, or reflecting it once and then reflecting it again. Because by reflecting it once, we change its orientation, right? We make it the mirror image. But then when we reflect it again, we get it back to its original orientation. It doesn't look like a mirror image anymore. It looks like it's facing the same way as it was here. So every translation could be thought of as a composition of 2 reflections across 2 lines that will be parallel, right? So if I was reflecting triangle ABC across line M, then I would have this mirror image of it, A prime, B prime, C prime. But then if I reflect that along the line N, which is going to be parallel to M, I'm back to where my triangle is facing the same way as it was originally. A couple things to note about this. Both of the reflection lines are perpendicular to the line containing a pre-image point and its corresponding image point. So what is this saying here? If we kind of understand what this is talking about, let me grab my pen here, and let's connect C to C prime and then on over to C prime prime. This line here, maybe I'll do it with an actual line tool here. Let me grab my line tool. Let me connect C. I'll connect them better here in a second. I gotta move that line. So there we go. connecting those 3 points, what we should notice is that that line connecting all of those C points is going to be perpendicular to each line of reflection. All right? And the same thing would be true if I connected all the B's together. That line would be perpendicular to each line of reflection, and then the same thing would happen if I connected all the A's together. The other thing to note is that the distance between the pre-image and the image, right, so the distance between here and B prime prime is 2 times the distance between the 2 reflection lines, right? So this distance from here over to here is 2 of this distance. And if I can, let me zoom in on this. Let's see if I can kind of point out why that is the case. All right, so let me zoom in. Now, I want to go through this, and I am going to put some values on some distances in this picture. All right, so first of all, I remember that when I reflect a point across a line, that point in its reflected point, its image, is going to be the same distance away from the line of reflection. So what I'm going to write is I'm going to write a little x right here and a little x right there, right, to show that this distance from here to here is x, and then the distance from that point, that line of reflection, to the new point, the image, is also going to be x. Then I'm going to put a y here and here, and what that indicates is the distance from B prime to the line of reflection is the same as the distance from the line of reflection to B prime prime, so I'm going to call it y. Now, if I look at the distance from end to end, that's going to be x plus y, right? From here to here is x plus y. But if I look at the distance from B to B prime prime, right? So I'm going to take that green segment and I'm just going to redraw it right here from where that's B, and then we got B prime here, and then we got B prime prime here. This segment, if you look at it in that picture, is broken up into an x here, a y here, and a y here. So the total length of B prime prime, that's supposed to be another prime there, that total length is equal to x plus y plus y, which is 2 x's plus 2 y's. The distance between the 2 lines is just x plus y. The distance from B to B prime prime is 2 x's plus 2 y. So that just kind of verifies this idea right here that the distance between the image and the pre-image, these 2 points, is double the distance between the 2 reflection lines. So if that idea on that previous slide was maybe a little bit confusing to you, let's take a look and see how we can apply that idea here. It says that we are taking the translation by a movement of 12 units right and no units up or down of triangle JKL, and we're viewing it as the 2 reflections over line M and then over line N of triangle JKL. So let's just draw out what this is saying is happening. So I'm going to start by drawing triangle JKL. It doesn't have to look like anything specific, so I'll just make it look about like this. Let me draw that a little bit better. So I got triangle JKL. And now that is getting translated 12 units to the right. So I know that in a translation, it's going to look the same. So here's what I'm going to do. I'm going to just grab this and move it over to here. Okay, so it got slid 12 units over to the right. So this L got moved over here to L prime. I guess I'll put those, I'll call them L prime prime, J prime prime, and K prime prime. That got moved 12 units over. But what we're saying really happened is we're viewing this translation, and all these points, K into K prime prime, J to J prime prime, they're all moved 12 units over. That's what a translation does, remember. But we're looking at that and we're saying, well, actually what we did was we flipped this thing twice. First we flipped it over line M, and then we flipped it again over line N. And so the question, just to draw this out, I guess, when we flipped it over line M, we got this, it kind of looked like maybe about like this. So we would have this triangle, or this is L prime, this is K prime, and this is J prime, right? It got flipped over. This thing flipped over line M, and then that flipped over line N to get to here. So the question is, what is this distance right here? What is the distance between M and N? And so we're going to use the idea on the last screen, the last slide, to realize that if all these points got translated by 12 units, right? This moves 12 units over to here, K moved 12 units over here to K prime prime, and J moved 12 units over here to J prime prime, then the distance between these two lines, if I'm thinking of that translation as this series of two reflections, the distance between those two lines of reflection is going to be half of the distance that the points moved from here over to there. So if they moved 12 units, then that distance right there is going to be half of 12, or 6 units.